Hey everybody, today is Friday, January the 15th, 2021, and we finally made it to Friday, so I'm excited about that. Woo! Today we're going to continue to talk about strategies for division, and we've been using repeated subtraction. Today we're going to take that repeated subtraction and we're going to put it on the number line. So today we're going to actually use a number line to model it. So I want you to think about how we've been working with division using repeated subtraction. How would that look if we were actually putting it on a number line? So remember that we do have that virtual manipulative slide that you can use that number line on, and that's the one that I'm going to be using today as we work through this lesson. So our lesson objective is still going to be using models to solve division problems involving repeated subtraction and recording those solutions using a division number sentence, which all of you are doing really well writing. Our first problem is going to be about a baker. A baker has 49 cupcakes. He wanted to have 7 cupcakes in each box. How many boxes of cupcakes will he have? So I want you to think about that. And then we're going to place that on the number line. So I'm going to go over to my number line and let you see what that's going to look like when we use repeated subtraction on that number line. So remember when we used the number line before, we wanted to change the layout. So you can go down to the bottom here. And remember, we want no ticks. So that it'll make it easier for us when we're trying to solve those. And we know, and I'm going to go ahead and write up here what our problem is that we have. We know that we have 49 cupcakes, and the baker wants 7 in each box. We need to know how many boxes of cupcakes we're going to have. So I'm going to put B for boxes because that's what we're looking for. Now, when we come down here, I know that I'm going to start out with a number 49 because that's my total. Remember, we talked about what each one of these represents. This would be my whole. This is a part. And when we know the whole number and a part, it tells us that we're going to divide. Remember that slide that I showed you the other day to let us know that we're going to find the other part. So if we know a part and we know the whole, then we know that we're going to be dividing. So I'm going to start out with 49 on my number line, and then I'm going to think about how I could make it work to go backward. Remember, we're going to be hopping backward because we're going to be subtracting. Not sure why I have all those on there. Because we're going to be subtracting. Now, each time that we hop, remember how we did those hops before. I'm going to go ahead and place this here, but the problem is my hops are not going to look like that. I'm going to be going backward on this number line. So each hop, based on our problem, has to equal 7. So every time that I hop, it should equal 7, okay? Because they have to be equal hops. Not sure why I can't get that to go there, but okay, we'll do it that way. It has to be equal to 7 each hop. So we're going to start with the repeated subtraction. So we're going to start out with 49 minus 7. And hopefully you've already subtracted that, and you know that 49 minus 7 is going to equal 42. So I'm going to click and put 42 here. And then we're just going to keep repeating that. So I'm going to do the exact same thing again. I'm going to do another hop. This time I'm going to hop back 7 again. And in this one, my answer should be 35. So that's going to be 42. And this is going to show you what that looks like as you hop across that number line. Remember, Miss Bays is not a very good writer here. So 42 minus 7 gives you 35. Now, I'm going to go back here, and I'm going to hop again. And this time, I'm going to hop back 7. And I know that's 35 minus 7 gives me 28. So I'm going to go ahead and put another hop there. Oops. And that's going to go back 7 also. So on the number line, this is just looking exactly like what it would look like if we were doing it with repeated subtraction. So Let's scoot that down just a little bit. My hops look bigger, but it shouldn't be. But it does look it. It's okay. So this one's going to be 35 minus 7. And that gives us 28. Now we're going to do another hop of 7. And that's going to equal 28 minus 7. And we now all know that 28 minus 7 equals 21. Oops. 21. And then we're going to do another hop until we get to 0, or a remainder that can no longer be subtracted. We're going to keep taking that away and hopping back. So now we're going to hop back 7 more, and we know that we're going to do 21 minus 7, and that equals 14. So I'm going to go ahead and write up here 21 minus 7. We're seeing that whole process play out now that we did. Oops, this should be 21. Sorry. 21 minus 7 equals 14. Now we're going to hop again. So I'm going to come down here and get me another hop. And 14 minus 7 oops, don't want to do that. Don't want 7 there. That's going to be, well, actually, it is going to be 7. I don't know why I did that. It is going to be 7. So 14 minus 7 gives me 7. And then I'm going to do one more hop. And that hop's going to also be valued at 7. And when I do 7 minus 7, I get 0. So in this case, I cannot subtract anymore because I have a 0. Or if I have a number less than 7, I couldn't subtract anymore. So I'm going to go up here and show you the subtraction for this part. It was 14 minus 7. And this one is 7 minus 7. So it gets us to 0. So this is what it would look like on a number line if I were doing this problem. Now, if I count how many times I hopped, that's going to give me my answer for my problem here. So let's start counting. 1, 2, 3, 4, 5, 6, 7. So the answer to this problem is going to be 7. So B is equal to 7. And you could write that as 49 divided by 7 equals 7. So if I'm doing repeated subtraction on a number line, this is how the problem would look. And I'm going to, so remember, you can go down here. I'm going to come down here and I'm going to clear this off, and then I'm going to start a new problem. So let's try one more. So this problem is going to be about a field trip. Highland Elementary is taking a field trip to the Kentucky Derby. The third grade teachers have 54 students all together to take on this trip. The buses they have rented only carry 6 students. How many buses will they need to make this trip? So we're going to go over. So we're going to use our number line again. We're going to go over to this number line. And I already know that we have 54 students. Oops. Try that again. 54 students. And the buses only hold 6 students. We're looking for how many buses we will need. So I'm going to use a B again since it represents buses. But you can use any variable there. Remember, this is our whole. This is our part. And we're looking for this part. We don't know what it is. It's still a question mark. So we're going to start out with our number line. And I'm going to go ahead and start out with 54. And remember, we are going to be hopping backwards. So when you get this up here, you can pull it down, and then you're going to pull it the opposite way. So you've got your hops. And I know that I'm going to be hopping 6 each time. So I'm going to start subtracting. And 54 minus 6 is 48. And again, I know that this is 54 minus 6. So just think about the number you're starting with. That's going to be what you're subtracting each time. I'm not going to show you that again on this one, but remember that you are subtracting there. And now we have 48 minus 6. And that's going to give us 42. So we can start seeing that number coming together for us. We're going to subtract again. 42 this time minus 6. And that's going to give us 36. And remember, our hops are equal. Miss Bases don't look so equal, but they are equal because they have to be equal to work out this problem correctly. Remember, we're talking about how it's equal groups, equal shares. And in this one, it should be 36. So now we have 36 minus 6. And again, our next hop is going to be here. And that's going to give us 30. Because 36 minus 6 is 30. And then we're going to take another hop. Of 6. Can't seem to get my boxes straight, but you get the gist. It has to be equal though. And 30 minus 6 is 24. Hop again. 24 minus 6 is going to be 18. Hop again. Hopefully I've got enough room for all of these. I have to scoot them over, but hopefully I will before we get finished. Minus 6 again is going to give us 12. And then we're going to minus 6 again. So 12 minus 6 gives us 6. And then we're going to have 6 minus 6 will give us 0. Now, there are times, and if you watched my video yesterday, there are times when you may have a remainder. A remainder means that there's something left over that you can't share equally. Now, in a case where it's just passing out, like in the marble game in the video yesterday, you could just leave those out. You don't have to worry about them. You just know that there's a remainder too. But if it were a situation where I was taking kids on a bus ride for a field trip and I had more kids than what I knew that the buses held, then I would need to get another bus for those kids. So I would have to increase my amount here to something different. So I'm going to count those 6's here, and I need 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to need 9 buses. So B is equal to 9. But if I would have had 56 kids, and they only held 6, then I would need another bus. I would need 10 buses. So it depends on how you want to look at that remainder. For us, if there had been a remainder, we would have had to look at it differently in this situation. But since we have an equal number that ends in 0, and we don't have any remainders, then the answer to this problem is going to be 9. I hope this helps you see visually what it looks like when you're using repeated subtraction on this number line. If you have any trouble, always hop onto the whole group Google Meet, and I'll be there to help you in any way. Thank you. Have a good day.